How's it going, class? This is Mr. Miles coming at you with a podcast. Today, we start a new chapter. So we're looking at Chapter 4, Lesson 1. And if you're following along, it's going to be found on page 138. So today we're going to be talking about what is an animal. Okay. So the first question we want to ask is, what are the functions of animals? Some animal functions. The main functions of an animal is they need to get food, they need to get oxygen, remember that's O2. They also need to keep in stable internal conditions, and remember that's called homeostasis. They need to be able to move in some way, that's very important. And also they need to be able to reproduce. So these are the functions of homeostasis. Okay, so these are the functions. And the question you may ask yourself is, how exactly do they do that? They do that with something called an adaptation. And an adaptation can be one of two things. It can either be behavioral or it can be physical. So behavioral or physical. When we talk about certain animals like rabbits, you notice that rabbits are very skittish, and I'm wondering what skittish means is if they see somebody or if they see like a dog or even you notice they'll kind of freeze for a second and then they'll take off running. Even if you're trying your hardest not to pose a threat to rabbits, they try and run away. That's behavioral. That's a behavioral adaptation, and it's just a way that their behavior enacts them to survive longer. You can take something like a crocodile, and they're extremely aggressive. Same thing with sharks, especially with their food, is they don't really hesitate the same way that a rabbit's going to hesitate. And the reason is because they need to be aggressive because they don't want their food to get away, because usually the food that something like a crocodile or a big cat like a lion or a tiger, they're going to be very skittish, they're going to try and run away. So to counteract that, their behavior has to be very aggressive. Now the other thing they can have is they can have a physical adaptation. Now for the rabbits, if we're going back to them, so let's get a little visual here. So here's our cute little furry rabbit. There's his eyeballs. If you notice about rabbits, they have extremely big and powerful back legs. This helps them to be very fast. And so the behavioral thing tells them to run, and it creates them to be very nervous. And those back legs, the physical adaptation, allows them to move very quickly. If they didn't have that, if they had short little stubby legs and couldn't move quickly, they would be eaten a lot, and they really wouldn't be very successful as a species. Same thing with crocodiles. If crocodiles didn't have those sharp teeth that could hold on to animals, that could tear through flesh, they would starve to death because animals would be able to get away and they wouldn't be able to chew them. So there's behavioral and physical adaptations of animals. Now, the next thing, which is very important, because as humans, as I told you at the beginning of the year, we like to classify things. We like to put things in groups. So how exactly do we group or classify animals? Now, the thing is that there's 1.6 million different species, and new ones are found every single year. And so they need to put them into different groups. And so scientists have classified them into 35 groups. And we're going to look at some of the groups on page 140 through 141. And we're going to get into more detail about these as we go through all the different animal parts. But the basic ones we're going to get is we're going to get sponges. We're going to get cnidarians. We're going to get flatworms. We're going to get segmented worms. Let's put S worms, segmented worms. We're going to get mollusks. We're going to get roundworms. Now let's go down with here. We're going to get arthropods. We're going to get echinoderms. And more familiar ones like the fishes, the amphibians, the reptiles, birds, and our favorite, the mammals. And so these are the groups that we're going to be dealing with. And all these things, they're connected through something that we call a common ancestor. And we talked about that at the beginning of the year. And what the common ancestor is, there was a point in time where there was a singular species and it split off, where you got the sponges and you get the cnidarians, because you can see traits that have them related to one another. This animal group right here would have been its common ancestor. And the flatworms, depending on when they came about, they could have come from a common ancestor that had already started with the cnidarians, or it could have come back a little bit further. And you will draw this, and you guys remember this is called the taxonomic tree, and you draw this to see the relations between it. And this is a really good thing because it helps to show you which ones are more closely related. So if you're looking on page 141, you can see the reptiles and birds are very closely related because they both came from a pretty recent common ancestor all the way up here. But if you look down at mammals, they come from a common ancestor with those guys all the way down here. So they had already split off from the mammals, the reptiles and birds did, when it came over here. So you can see that these two are more closely related than these two would be. And you do that taxonomic tree and you just see where the branch comes, and the more recent the branch, the more recent that common ancestor that they shared. Now another thing that's important to see is you have something in here called the vertebrates and the invertebrates. So we have the invertebrates and the vertebrates. And this is just simply talking about your backbone, the part of the bone that protects your spinal cord, and then in means no backbone. So you have the vertebrates, so those with backbone, and invertebrates, so those without a backbone. And where it splits is it splits right here. So this group all in here will not have a backbone, so they will be known as invertebrates. The fishes, amphibians, reptiles, birds, and mammals will have a backbone. And if you've ever seen a fish skeleton or an amphibian skeleton or reptile or bird skeleton, you'll know that they do have bones that comprise a backbone. And if you've ever seen a sponge, cnidarians, flatworms, any of those, you know that they do not have the same kind of skeleton that we have. Probably the one you're most familiar with is probably the arthropods, with the insects, with the arachnids like spiders, lobsters, and you know they have an exoskeleton, meaning they have that hard out, like, you think of it like their skin is like their skeleton. It's the hard outer layer, but it's soft and gooey, and inside they don't have an inside skeleton like we do. So that's lesson 4.1. If you have any questions, just let me know. And again, just read through the book if you want to go over the groups and figuring out which ones are more closely related and which ones are vertebrates and which ones are invertebrates. Okay, until next time, I'll talk to you guys later.